right, folks, it's Bass Action back in action here. In this video, we're going to look at how to use the row operations discussed in the previous video to solve systems of equations. Now, what I want you to first notice is that we are going to use some processes here called Gauss-Jordan elimination and row echelon form. In this video, I'm going to go through the processes, but we're often going to leave our answers in a non-technically correct final form, and that's okay for this class. It might not be okay in future classes, but don't worry, those classes will cover whether or not that's an expectation. All we're concerned is how we can use row operations to do this process. Now, in order to do Gauss-Jordan elimination, we need to understand the difference between these two types of matrices because they're used for different things. Gauss-Jordan elimination in this row echelon form use an augmented matrix that will be created by the entire system of equations. A coefficient matrix will only be created using the coefficients. It will not include the constants of the matrix. The coefficient matrix is going to be used later in this chapter for other methods of solving systems of equations, okay? So this one will be used later. We're not going to completely ignore it. So for today, we're only interested in the augmented matrix. So that's going to be our first example on this video, is to just create an augmented matrix. So looking at the system that I have here, what I'll do is I'll start off some nice brackets, and then I'm going to go ahead and grab all of these values that I see here, all these integers. So I'll have a 1, I'll have a 3, a -5, and a 6. And then on the next equation, I'll have a 2, and I notice a variable's missing, so I use a 0, a 4, and a 5. And then the next one, I have another 0, and then I have a 3 and a -2, make that a little bigger, and a 7. And then I can close my bracket. Now, what a lot of people like, although I don't generally do it, what a lot of people like, and is technically part of it, is this nice vertical line where the equal sign would be. It separates the variables from the constants, and it helps be able to visualize what we're trying to solve for. When we're solving, what we're going to be trying to do is create the multiplicative identity matrix, meaning we're trying to get some ones all the way down this side. So this part should turn into an identity. So we want ones down this diagonal, and we want everything else to be zeros. For our purposes, what we're going to be looking for is that we just have a 1 and zeros, and then a 1 and zeros in other spots, and a 1 and zeros. As we get into the example, I think it'll make a little bit more sense. Let's go ahead and write one more augmented matrix, make sure we're good with that. So we have a -3, a 4, a -2, a -5, 0, 0, 1, 3. You do need to make sure that the variables are in the same order for each equation. 5, -2, 6, and 10. We'll close that bracket, and if you want, you can go ahead and include the vertical bar. It's totally up to you. You'll see that I don't use it a lot of times. It's just a little bit more for me to write, and my brain can kind of separate the parts that I'm focusing on. Okay, so let's look at a system of two variables, and I've found for many students the system of two variables sometimes turns out to be harder for them than the system of ones, mostly because, or system of three, mostly because it's almost too simple. So we'll start by getting our augmented matrix. So we'll have a 2, a -1, a 12, a 4, a 3, and a 14. And again, if you want that vertical bar, you can. So what we're trying to do is we're trying to create this to be ones and zeros, and this to be a 1 and a 0, okay? Being opposite. Now, something you might want to write down is that in general, what we're trying to think about is we're trying to use anywhere we can have a 1 to create a 0 below it, okay? So we're going to use a 1 to create a 0. And in general, until you get comfortable with it, try to stick with keeping one row the same and only changing one row at a time. That'll help a lot until you start to get comfortable. So, for example, on my first altered matrix I'm going to use this 1 to create a 0. So I'm going to keep this row the same. So to help keep myself straight, I'm just going to write that row right off the bat. I'm going to rewrite it to help me remember I don't want to change it. Okay. Then what I'm going to do is to create my new second row, I'm going to take the first row and I'm going to multiply it by a 3. So I'm going to do 3 times row 1, and I'm going to add it to the row 2 that I have here. And when I do that, I have a 3 times 2 is 6, plus the 4 is going to give me a 10. And then I'm going to have a 3 times my negative 1, plus my 3 is going to give me the 0 that I wanted. And then I'm going to do a 3 times my 12, plus my 14 is going to give me a 50. Okay. Now, a shortcut that you can do, and I will allow you to do this, now that I look at this row, I can see that if I divide this whole row by 10, I will create a nice 1 right here, which is my goal. Technically speaking, we should write this as a middle step. I should try to rewrite that. Now, another option, I can either rewrite the whole matrix, or what I can do is I can mark it out, or a third option is to go ahead and say, okay, I'm going to mentally just divide that right now, 0, 1, 5. I'm dividing that whole row by 10. And now to create a 0 and a 1 in this row, I'm going to use this altered row, okay? So if you had wanted, you could have just marked that out and written 1 and marked that out and wrote a 5 right there. Would have been fine with me. So how can I use this to create another 0? Again, we use 1s to create zeros. So we want to use this 1 to create a 0 right here. And we can do that by taking a negative 2 times my row 2, and I'm going to add that to my row 1. Sorry, my voice is kind of going. All right, then, so a negative 2 times the 1 plus that 1 is going to give me a 0. Of course, it doesn't matter what I do to the 0. If I add it to the negative 1, I still have negative 1. Negative 2 times 5 is a negative 10, plus my 12 is 2. Sorry, I lost track there of myself for a moment. And then that would mean that we can take that new row there, and we can divide that by a negative, or again, you could just mark it out. I'd be okay with that. 1, negative 2. And then we'll have our 1, 0, and our 5. So technically speaking, we should flip-flop these two rows so that this 1 is in that first spot, but I personally don't care. So what I want you to know is that this column represents the y's and this column represents the x's. So we're going to have a y equals a negative 2 and an x equals a 5. So our final answer written as an ordered pair is 5, negative 2. That's our final answer. Okay. Now, I'm going to stop this video here, and I'm going to make a separate video for the system of 3 there, because that's going to be kind of a long process too, and that way you've got 2 separate videos instead of having to slog through 2 long ones. So the next video will finish up this page of examples, and it will cover that system of 3 variables.